The power rule. The power rule. You have discovered the power rule. If you have x to the n power, that n comes out in front as a coefficient, and your degree is 1 less.
You can just learn this first.
Yeah, why?
I've had so many headaches.
You have to understand what we're doing.
Well, now we're just going to be doing this.
Right, but we needed to go through that process of what are we actually finding, okay? I know that taking the limit definition of the derivative is very time consuming. So here, let me save you some time. Here is the power rule.
Appreciate it.
You're welcome. Okay.
Is d over d of x the same as saying that
Right, so remember d over d of x means take the derivative of whatever's next to it. So take the derivative of ax to the n. Okay, so now in here they have that a out in front. So if you already have a coefficient, then that power gets multiplied to that coefficient. Okay. Now, do you see why I rewrote?
Yeah.
Okay, so here we had the square root of x, and I wrote it for you as x to the 1/2, right? So then our derivative, we can use this power rule to take. Okay. Alright. So, are you ready to do some examples?
But what about if you're like have an addition after that? What happens then?
What do you mean addition?
Take the power after the x.
So, okay, so like number 2, like pod 4 over here had x squared plus 4x. So we can apply the power rule to x squared plus apply the power rule to 4x.
Okay.
Okay, so we can just do it individual times. Okay, so let's look at some examples. Okay.
Rewrite if needed. Good job.
Okay, why did I say rewrite if needed? Okay, if it does not look like x to a power, rewrite it to x to the power so we can use the power rule. Okay, so our derivative would be what? 6x squared. The 3 comes down to multiply with the 2, and x is 1 power less. Okay. This may be a time where we should what?
Rewrite.
We should rewrite it. So I'm going to rewrite this as 1/3 times x to the 1/3 power. Okay. And so when we take the derivative, what is our coefficient? 1/9. We take 1/3 times that power goes in front, and now x is to the what power? What?
Negative 1/3 power. Negative 2/3.
Okay. Let's go back to our power rule. Our power decreases by 1. So we have to take 1/3 and subtract 1 for a negative 2/3. Okay, so then we could rewrite this as 1/9 x to the 2/3. Because we don't really like negative powers. Okay, we like them to be positive. Okay, so this is how I would probably want you to rewrite it, okay?
But I thought you said we could do it simplified.
Correct.
But
When we're talking about like numerical values, okay, when we're talking about equations, there isn't to a certain extent you still need to simplify. y equals 6 over the 5th root of x cubed. What are we going to have to do with this one? Rewrite it. This is 6 times x to the what power? Negative 3/5. Okay. So this is y. I'm going to go ahead and write dy dx. That still means derivative. You can also say y prime. Okay. So the power gets multiplied out in front. So what's our new coefficient? Negative 18/5 times x to the negative 8/5. We have to subtract 1. So negative 18 over 5 x to the 8/5. If you wanted to write it as the 5th root of x to the 8th, that would be fine because that's kind of how we started the problem. But I would accept either of these answers. Okay, either as just a strict power or if you take it with the root in power.
So on your negative 18 over 5x, is the power of the x positive or negative?
This is positive because it was negative, and so when we moved it to the denominator, it becomes positive. Right?
Okay.
Yeah. Yeah. I was waiting, making sure everyone had everything written down. Okay. All right. Let's keep going. Okay.
Why is it K?
Because we use C for something different. Okay, I know. So first of all, you guys, we've kind of already talked about this. Okay. I think Zach asked the question. All right, if we have multiple functions added or subtracted together, we can apply the derivatives individually. All right. So when we look at Pod 4's example was x squared plus 4x. When we take the derivative, we can apply the power rule to x squared, and then we can apply the power rule to 4x. Okay. And then the constant rule, if there is a constant, you can worry about it during the derivative or after the derivative. It doesn't matter. Okay? It's probably something that you want to take the derivative and multiply after, then you don't have to think about it while you're taking the derivative. That's fine.
Wait, so what would you do with the constant?
So like if you had, if f was 16x to the 4th, right? Well, we know the derivative of x to the 4th is 4x cubed, right? And then we can multiply 16 to that.
Or you could just do the power rule.
Yes.
Like, yeah, okay.
Yes. But we're going to learn some rules that aren't just power rule. Okay? So, we still can have this. While I'm thinking about it, we do have a quiz on Wednesday. On that quiz, yes, you will get to use the power rule, but I will ask you at least once to use the limit definition of the derivative. Okay. All right. A couple trig rules for you. The derivative of sine is a positive cosine. The derivative of cosine is a negative sine. These you just have to memorize. That's all I can tell you.
So we're gonna
Mm-hmm. Like today.
You know,
What?
cosine X
This
is
is
a
a
slide.
It's a slide.
Okay. So at least they're related, right? One's positive, one's negative. So you're gonna have to remember which one the negative goes to. Okay. Now, I do want to look at why the derivative of sine is cosine. Okay. So let's talk about the limit definition of the derivative. So the derivative would be the limit as h approaches 0 of the sine of x plus h minus the sine of x all over h. Okay. Now last year in pre-calculus, you had some sum and difference formulas, right? Where if you had a sum inside of your sine or cosine function, you could break it up. Okay, I'm not saying that that's something that you need to remember, but this is how I'm getting what I'm getting here. Okay, so if we have the sum inside of our sine function, we can break it up to the sine of x times the cosine of h plus the cosine of x times the sine of h. Okay, you probably remember doing that. It's not something that we had you memorize. It's not something that I expect you to know right now, but that's how I'm going to apply it to help me evaluate this limit. Okay. So now, what is true about the first and the last term? Huh? They both have what in common? Sine of x. So I'm going to factor out the sine of x from this term and that term, right? And then we have plus cosine x sine of h. And I'm going to break this up into two different fractions. Okay. Okay. I want to highlight something right here. Does this look familiar?
No, it's 0.
This limit is 0. Okay. And what about this?
1.
That limit is 1. So what are we left with?
0 plus
0 plus the cosine of x times 1. That is why the derivative of sine is cosine. This one?
No, the second triple.
The derivative of cosine is negative sine. Okay. We can also think about their graphs. This is kind of something that you looked at in class the other day with our graph next, Carly.
If when you factor the sine of x out, what happened to the second?
This one?
No, I mean, if you, yeah, what happened to the?
So since I factored out sine, we're left with 1.
Oh,
Okay.
I was looking.
Okay. Now with all of our knowledge about derivatives and their graphs, notice how here where we switch directions, the derivative is 0. Right? Okay. So that's why those two graphs are so similar. Well, that's one of the reasons. There's a lot of trig relationships, obviously. Okay, so let's do some more examples. This is something that is similar to what you will see again. Okay? What do you have to do before you take a derivative? You have to rewrite it. So if we're going to use the power rule, obviously we can't use the sine or cosine rule. The only other thing we know is the power rule. If we're going to use the power rule, how are we going to rewrite this?
The same as the denominator becomes 2x times, 2 times x to the 1.
We cannot do that. Oh, well, yes, okay. I see what you mean. So first of all, we should recognize that the denominator is 2x to the 1/2. Okay, now we have to split this up into 4 separate terms, right? So 2x cubed divided by 2x to the 1/2 would be what? So 2 over 2 is 1, and then we'd be left with x to the
6. Wait, are you dividing 3 by 1/2 or what?
no. We're subtracting.
5 1/2.
Thank you. When we divide, our exponents are subtracted.
Yeah.
Okay. Minus 3 divided by 2 times x to the
3.
plus 7/2 times x to the positive 1/2, right? X over x to the 1/2. And then plus 5/2 x to the negative 1/2. Now, what?
You get all those weird exponents or powers.
The powers, since we're dividing our x's, the exponents get subtracted. So this is 3 minus 1/2 is 5/2. 2 minus 1/2 is 3/2. Okay. Now let's take the derivative using the power rule. X to the 5/2 becomes what?
5/2 x to the 3.
Okay. Minus. Okay, we drop the power, so that coefficient's now 9/4, and then x to the 1/2. Plus, when we drop the power for power rule, that becomes 7/4 x to the negative 1/2. Now what's this coefficient? Negative 5/4 x to the negative 3/2.
Makes really complicated questions easier than the easy questions we have in classes.
Are you excited that I'm not going to make you do this one with a limit definition? How awful would that be?
Yeah, I would leave it.
Probably would take 10, 20 minutes.
Okay, I want everybody to do this individually.
You got it,
How do we apply the writing of limits? Like when we're writing it, or we just write f prime of x?
You would just write f prime of x equals. Turn to your neighbor and see if they have the same thing for their derivative.
You don't have to look down. Look at
What? Do the same thing. Do the same thing.
I'm still working on it.
Use your rules. No limits. No limits. No limits. What? What's the derivative of x?
It's supposed to be zero powers.
Yeah, no more of that. That's gone. Past.
She's no longer allowing you to do the hard stuff.
Well, you'll have to do it on this way.
What about all?
But now that I've shown you how to take the derivative using these rules, that's how we're gonna do it. What's the derivative of x? What's the derivative of cosine x? Negative sine x. So 1 minus sine of x. Done.
I forgot the rule, that's fine. I don't know, brain work.
Okay, don't forget it. Don't forget it. Are you asking about why it's 1?
Yeah.
Okay, so this is x to the first power, correct? So we drop the power to be 1 for our coefficient, and then now x is to the 0 power.
Oh, I changed it to 0. I thought it was negative.
Ah, yes, don't forget about that 0. All right. Write it down. Let's discuss this.
X plus
Okay, yeah, we should probably rewrite it, right? And to rewrite it, what should we do? Okay, let's actually multiply that 3x plus 2, the quantity squared out. 3x plus 2, the quantity squared, is going to get us 9x squared plus 12x plus 4. And then we can take this x through to get 9x cubed plus 12x squared plus 4x. Now this looks a little better, doesn't it? Applying the power rule to this is going to be much nicer. Our derivative. The derivative of 9x cubed would be what? 27x squared. The derivative of 12x squared. 24x. And the derivative of 4x. 4.
Wait, what? So if we drop the 1 down and then we do 0.
So x to the 0 power is 1, so you have 4 times 1. Yes. Yep. Yeah. Isn't this so great?
We just have a normal number of powers, it just dies.
A normal number. Yes, the derivative of a constant is 0. Good thing to remember. Okay? You guys aren't as excited as you should be. Like, you don't have to take the limit as x approaches 0 anymore.
It could be very scarred.
You're scarred.
Possibly.
Okay, so here's your all homework. A mixture of evens, a mixture of odds. Okay, check your odd answers. Check your odd answers. You want to know if you're doing this right, correct?